Okay, this is a question from physics where we can see a special which needs to solve it, it needs to have an a special understanding. Okay, the question is that when there is a wall given to you, let's say this is the wall, right? This is the wall given to you, right? And with this wall, two blocks are arranged like this is a block A, and with this another block B is aligned, right? This is definitely, if these two blocks are kept in contact with each other and the wall is like this is the wall. Let me write it. This is the wall, right? Then in that case both of these blocks will not be here. Okay, so just to hold this, a force is applied from here. That force is applied on B, right? Now into this question, it has been asked that considering the situation shown in this figure, the wall is smooth. The wall is smooth, right? Mind the word. The first term is wall is smooth, and the condition is wall is smooth. So from this line, what we understand, since the wall is smooth, that means there will be no friction between the wall and A, right? This is the first thing which came into our mind, right? What is the second thing? Let us read the question going forward, okay? But the surfaces of A and B in contact are rough. So this surface between which is the this surface, that means this surface which is in contact, right, with A and B, contact surface between A and B is is rough. So if the word rough is here, that means here at this point we have certain friction. Okay, at this point we have certain friction, and that friction have some coefficient, that is, let's say mu is the coefficient of friction. Okay, so into the question it's very clearly mentioned that considering the situation shown in the figure, the wall is smooth. As I have mentioned, that means wall is smooth. From this we can take one input that there is no friction force. So at this point the value of mu is equal to 0 because the surface is smooth, right? Now the wall is smooth but the surface of A and B in contact are rough. So if this is rough, this point, so that means contact surface between A and B is rough. That means there is a frictional force, and that's why there will be a coefficient of friction lying at the point of contact, which is between the two blocks A and B, right? Now the friction on B due to A in equilibrium. What is the friction on B due to A in equilibrium, right? It's upward. The question is this one is upward or downward or 0, or system is not, cannot be in equilibrium, cannot be in equilibrium. So this is the question, right? So how to solve this, let us see. Yeah, I think this is visible now. So students, here you can see if there is a force applied to this block, this is only holding this arrangement, right? So this force, when this force is applied on it, so if you draw the free body diagram of B and A separately, you can see the force which is acting over here and the frictional force, the friction coefficient of friction between the point of contact of A and B is mu. Then opposite to it, opposite to it, the frictional force will be lying. So since mu is there, so this, due to the weight of B, due to the weight of B, that is mass of B into G, this weight is there, right? So this will ask this block to move downward, right, due to this weight. But the frictional force in contact will be coming into picture because this is opposite to the direction of movement. So the frictional force will be acting here into this direction, right? Let me show it here. This is acting into this direction, F, right? But and this force will be acting here, and the normal force of this A will be acting like this on this normal due to A, right? Now here you can see this is the all these forces are acting on B, but what will happen on A? On A is also having its weight, right? So due to this, the mass of A into G will be the force which is acting downward on A, right? But this force which is acting downward on A need to be compensated with something. So what will be the forces acting upward over into this direction? This is nothing but the frictional force. But this is nothing but the frictional force. But will we have any frictional force over here? Because the point of contact between the wall and A is this one. This is the point of contact. And at this point of contact, the coefficient of friction is 0. Because the surface is smooth. You can see it's mentioned wall is smooth, right? So this mg, mass of A into G, the weight of A would not be compensated by anyone because the frictional force over here is 0, right? Frictional force over here is 0. So that's why this mass A will be going downward. So that's why from these four options, that is either the system will be upward, downward, 0, or cannot be in equilibrium. So this cannot be in equilibrium, and that's why our option number 4 is correct, right? Because this was asked to us that the friction on B due to A in equilibrium. So definitely there will be friction, but the system is not in equilibrium. This is the most suitable option. So that's why option number D or option number 4 is correct, right? And the reason behind the weight of G, weight of A, that is MA into G, going acting downward, will not be compensated. There will be no forces acting upward because this surface is smooth. You can see this surface is smooth. That is when A is in contact with the wall, that surface is smooth. So that's why the frictional force which is acting against this is the force which is acting downward. So that's why the A will be in a condition to move downward, and opposite to this force the frictional force will be acting, because frictional force is always acting opposite to the direction of motion. So here the frictional force will be the only force which would be in impact, but this will not. Why? Because the frictional force is equal to mu into n. That is, frictional force is the product of mu and the normal force, that is the coefficient of friction and the normal force, right? And here the mu between the wall and A is 0, you can see, due to which this frictional force acting upward will be 0, and that's why the mass A will be tend to go downward and downward, right? And that's why this entire system will not be in equilibrium. So this cannot be in equilibrium. The fourth option is the most suitable option, and that's why we have chosen it, right? Thank you so much for watching, students. I hope it will help you to build some concept on friction, right? And understand the basic understanding on this. And when you solve different types of question on friction, on the different concept of your physics, okay, then you will have a better grasp over the topic, okay? And yes, for any query, you can put up into the comment box, and if you find it useful, you can like it. Thank you so much for watching. Happy learning. Take care. Bye bye. See you, students.